Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 12.2, Problem 11. This is Section 12.2, Problem number 11. It says, find the equation of the line that is tangent to the function f of x equals x squared plus 7x minus 8, in parentheses, times 4x to the third power plus 5, in parentheses, at the point where x equals 0. And then there's a big hint that goes with this. So we're looking for the equation of the tangent line, is what the problem says. And in the hint, it explains that when a line is tangent to a function, it touches the graph of the function at just one point, and it has the same slope, same amount of tilt, in other words, as the slope of the graph of the function at that one point. And since the tangent line, this one is the tangent line, the straight line, since it's a straight line, you can use the formula y minus y1 equals m times x minus x1. Again, m being the slope, which we can find with the derivative. The y1 and the x1 will be the x and y values of this point where it touches. And the rest of the formula, parentheses, the y, the x, the equals, that just stays in our answer. So we're working with the function f of x equals x squared plus 7x minus 8, in parentheses, times 4x to the third power plus 5, in parentheses. And what we have, there was a graph in the hint, and it shows that there's some type of line that touches a straight line at one point, and we're looking for the equation of that straight line. So whenever we have the equation of a straight line, we use the formula y minus y1 equals m times x minus x1, and we have to find a number value for 3 parts of that formula, and the rest of the formula stays. We have to find the number value for y1, for m, the slope, and for x1. Now, it wants us to find the equation of this tangent line when x is 0. So this is kind of a generic graph, really, when x is 0 is back here. So I have, for my point that I put in the x1 and the y1, the x coordinate already at 0. 0. Now, I am going to need the y. So before I even start doing a derivative, no f prime yet, I'm just going to do f of x and put in a 0. And the output I get will be the y coordinate that goes with that. What's the height of that point? So no prime yet. This is still f of x, and it's f of x evaluated at 0. F of 0 equals, so x squared becomes 0 squared. 7x becomes 7 times 0 minus 8 times 4x cubed, so it'll be 4 times 0 cubed plus 5. Well, the zeros are especially easy to work with. The first set of parentheses just has a negative 8, right? Very easy to lose the negative. Pay attention, it's negative 8, not just 8, times 5. This 4 times 0 cubed, that just drops out too. So negative 8 times 5, which is negative 40. So the whole thing, to finish it from here on out, boils down to finding the m, the slope. And that's what the derivative does for us. So the f of x that's given, we have to find the f prime. And the f of x is a product. It has one thing times another thing. And I cannot just take my derivative without clearing my parentheses unless I use the product rule. You could clear the parentheses, but most books that ask a question of this type, it's the intention that use that product rule. The first piece of the product is typically labeled as a u, which would be the first set of parentheses, the x squared plus 7x minus 8. And the second part of the product, the second parentheses, 4x cubed plus 5, would be labeled as a v. And the derivative, f prime of x, would be u prime v plus u v prime. So let's fill that in. f prime of x equals, so u prime. U is x squared plus 7x minus 8. U prime is the derivative of that. So the 2x has a derivative, the x squared has a derivative of 2x, right? The exponent comes down times the number in front, which is really understood to be a 1. The exponent of 2 comes down times the 1 in front, gives me a 2x, 1 less power, 2x to the first. The plus 7x in the middle of the u parentheses has a derivative of just plus 7. Again, when it's an x to the first power, the derivative is whatever's in front of the x. The minus 8 on the end has a derivative of 0 because it has no x with it. So really it's 2x plus 7 minus 0, which is 2x plus 7. That's my u prime. Next piece is v. No prime, just v, so just the second set of parentheses, 4x cubed plus 5. That's the v. Then plus u with no prime. So u with no prime is the first set of parentheses, x squared plus 7x minus 8. So I put that in for u, x squared plus 7x minus 8. And the last part of my product rule is v prime. So v is 4x cubed plus 5. V prime is the derivative of that, which would be 12x to the second. And that 12x to the second comes from the 4x cubed. The derivative is the 3. The exponent of 3 comes down times the 4, the number in front. 3 times 4 is 12. X to 1 less power. That third power drops down to a second power. And the 5, again, has no x with it, so its derivative is 0. So now that's my f prime of x, which could be simplified. It doesn't have to be simplified. This tells me the slope of my function at all points that I might want. So I'm interested in the point with an x-coordinate of 0, because that's the point that the question asked me to find the slope for. That's what I need to finish off my equation of a straight line formula. So now that I have my f prime of x for any x, put in an x of 0. So f prime of 0 equals 2x plus 7. When I put in a 0 for x, it just becomes 7. The 2x is gone. And then 4x cubed plus 5 becomes just 5. The 4x cubed, when I put in a 0 for x, becomes 0. It's 0 plus 5, which is 5. And then plus x squared plus 7x minus 8. When I zero the x, becomes 0 plus 0 minus 8, so it's negative 8. And then the last parenthesis, 12x squared, becomes 0. When I put in a 0 for x, 0 squared is 0 times the 12 in front. So 7 times 5 plus negative 8 times 0. Well, negative 8 times 0 is 0, so I can just really get rid of that. 7 times 5 is 35. So that's the slope, 35. So now I have everything I need to fill in my formula for the equation of a straight line. So y minus y1 is y minus a minus 40, which is really going to become y plus 40, right? Two negatives, one from the formula having a minus in it, and the other from the fact that the y coordinate is negative 40 that we got from some previous work. Then equals, then the answer for m we got was 35. Then a parenthesis, then an x, then a minus, and then the value of x1 is 0. And now it's almost irresistible for me not to simplify this a little bit. This really is the equation of the tangent line. And in reality, like, we could stop here, but y minus a minus 40, I almost have to make that y plus 40. And 35 times x minus 0. Well, x minus 0 is really just x. So 35 times x is 35x. And now at this point, I almost have to put it in y equals mx plus b form. Let me just bring the 40 over here. You really don't have to. Like, if you stopped here, it would be good. It would be the answer, but y equals 35x. Now, the 40 on the left-hand side of the equal sign is positive, but when I bring it to the right side, it'll become minus 40. So the final answer, the equation of the line that is tangent to the function at that one point with an x-coordinate of 0, is y equals 35x minus 40, even in its simplest form.